Hi guys, this is Mr. Urrego. Welcome back to our Geometry EOC review. We're solving a computer-based practice exam from the official Florida End of Course Exam website. So this is official, guys. Let's get to number 11. Miss Henry gave her students an incomplete proof as shown. So I'm reading. I have a drawing, given information. We have to prove that these angles are congruent. Let's go through this. This is the proof. Blank number 3, blank number 6 from reasons. On the bottom, I have reasons. So reasons number 3, I choose from here. Reason number 6, I choose from here. I believe this is, let me see, drag and drop. Excellent. All right, cool. Now I know vertical angles, alternate exterior angles, alternate interior, and corresponding. Got it. So I went through the answers. Okay, I need to fill the 3 and the 6 for the reasons. All right, I know what to do. Now let's read the problem. So given HQ parallel to HQ, this line is parallel to TX. Okay, these two lines are parallel. What is this given? Angle F and H. F and H, this angle is congruent to NPR. What's NPR? NPR. That's given. Prove. Question. RVW, let's change the color. Let's get to blue, I guess. RVW, so this angle, I have to prove that that angle is congruent to XWZ, XWZ. All right, I don't see relationship right now, but let's see. First step is statement 1 and 2 is they're giving. Number 3, they're saying F and H. Let's change the color, something greenish, I guess. F and H is congruent to RWV. F and H is congruent to RW. Oh, okay. They're saying that this and this are congruent. Yes. Guys, if this line is parallel to this line, then the position of NF and H and this, the green, right now the green, let me color the whole angle. The green angles, those are corresponding angles. All right, so I just need to scroll down and go to reason number 3, corresponding angles. Got it. Okay. Let's go back. All right, my lines got moved. No problem at all. We just proved that one. Okay, so let's go back. Next one. Let's keep going. So I already know that this angle is corresponding to this, and that the F and H is congruent to this, right? To NPR. All right, and they want me to prove something else. Let's keep going. RWV, okay, this is congruent to XWZ, okay. They're saying that these two are congruent. Yeah, that's called vertical angle, that's right. F and H is congruent. F and H is congruent to XWZ, yes. Transitive, yes. Okay, so what's happening in transitive, guys, is the following. All right, they're saying the F and H is congruent to RWV, and then RWV is congruent to this. So let's call this number 1 and RW number 2. So number 2, and then XWZ is number 3. So transitive, if angle number 1 is congruent to angle 2, but angle 2 is congruent to angle 3, then the first angle is congruent to the last angle. That's called transitive. Okay, when I have 3 things, 3 angles, 3 lines, whatever, 3 things, transitive makes sense. Next, NPR. Let's change the color. Let's get to that again. NPR, this angle. Okay, well, that's kind of blackish, whatever. NPR, that angle is congruent to RVW. RVW, okay. RVW. Nice, okay. What's the name of those two? So guys, again, look at these 2 angles. If the 2 lines are parallel, if this line is parallel to this line, then the relationship between those 2 angles, those are called alternate interior angles. Alternate interior angles. Look at transversal. Let's do a look transversal. All right. Look at the transversal right now. This is my transversal. So those two are alternate interior angles. Therefore, that's my reason for number 6. I'm gonna link a video about all this topic, explain all the names. All right. So these are alternate interior angles. Let me scroll down and get the reason. Alternate interior. Here we go, and that's number 6. Alternate interior. Make sure that we paste it right there, and we're done. Double check alternate interior, and the other one are corresponding angles, and that's number 11. Let's get to number 12. Question number 12. Trapezoid ABCD is inscribed in circle O. Diagonals BD and AC meet at a point E. AD is parallel to BC. AD parallel to BC. Okay, as shown. Select the angles and value to make a true statement about trapezoid ABCD. Alright, a couple things that I can notice here, guys, the following. Yeah, I clicked something by mistake. I'll fix that in a minute. So, first of all, they're saying trapezoid is inscribed. Alright, so trapezoid is inside. Okay, and now they have this. One angle equals to 90 or 180 minus another angle. Alright, what comes right through my mind is there's a property about inscribed trapezoids, which means opposite angles are supplementary. Okay, let's do that with red, and let's do the other two with blue. Opposite angles, and put a dot on the outside, and a dot on the outside. All are different. I'm not saying they're equal. All of them are different, but opposite angles are supplementary. Means angle B and angle D equals 180, the sum of those two, and angle A plus angle C equals 180. I think this is where this is going. Okay, so let's find the angles. Let's clear this out. Let's find the angles. Like I said, ABA, disregard ABE. I just clicked on a mistake. Okay. So this angle on the top is ABC. This angle on the bottom is ADC. This angle is BAD, and this angle is BCD. Alright? So remember, 3 letters. ABC. ABC is this angle on the top. So I can say that this angle plus ADC equals 180. Alright? ABC plus angle ADC equals 180. Alright, but here they're not saying that. They're saying one angle equals, I will choose 180 minus the other angle. So let's say angle ABC. Let's choose angle ABC. Angle ABC, if I only the angle ABC by itself, I gotta subtract this thing. So I'm gonna do minus angle ADC here minus angle ADC here. And now this cancels out, and I have angle ABC equals 180 minus angle ADC. Alright, so you have to think. Trapezoid inscribed, opposite angles are supplementary. The sum equals 180. But they're not giving you one angle plus another angle of 180. They're giving you a subtraction sign. So therefore, you have to say, alright, so let me subtract one angle on the other side. So now angle ABC is equal to 180 because they're supplementary minus angle ADC, which is this corner. ADC right there. So that is true. Okay? Opposite angles, and that's my right statement. Opposite angles are supplementary. Excellent. Very nice. Let's go to number 13. So 13. Oops. Catherine is using triangle ABC, the big triangle where DE is parallel to AC, DE parallel to AC. To prove that a line parallel to one side of a triangle divides the other two sides proportionally. Okay. Part of the proof is showing. Alright, so let's look at the whole thing. We always look at the question, what is given, look at the drawing, look at the proof. Okay, multiple choice, very nice. The question is, which statement completes step 8 of the proof? But the reason is already given. So what they want is the statement. Remember, the first statement is always the given. The last statement is what they want us to prove. Alright? So here we can narrow down our answers really quick. Let's go back to the question because they're not saying prove this. Okay, so let's find out what the question is. So the triangle, those two lines are parallel. All right. Where DE, all right, so Catherine uses triangle where DE parallel to AC to prove that a line parallel to one side of a triangle divides the other two sides proportionally. Got it. So this is what she wants. So what they want right now is to prove that, let's take this, that this side is proportional. So hold on. So this side is proportional to the little one, and this side is proportional to the other one. So they're saying this line parallel divides the whole line proportionally. Through line parallel to one side of a triangle divides the other two sides proportionally. So they're saying that this line divides BD or DB proportionally to AD, and that BE or EB is proportional also to EC or CE. Alright, so that's the idea. They're saying this line divides BA into proportional sides and also divides BC into proportional sides. So that's what they want me to prove. Again, last statement is the proof. Prove this. That's the question, last statement. So let's write somehow this question. They want this proportional. As you notice, they have fractions on the bottom. So let's do fractions. So let's say that BD, you know what, let's use color code. It's easier. Let's use color code somehow. BD, BE, all right, now let's use blue to finish the statement. So let's say I made a mistake. BD, all right, it's only this piece is from B to D. All right, from B to D is proportional to DA. BD is to DA light. BE, red, is to the little piece, EC. Oh my god, this is horrible. What's going on with me, my writing? So here we go. This is the proportion that they want. This line divides the line proportionally, so proportion BD is to DA like BE is to EC. Again, I can write that order of the letters, or I can just flip the letters. I can say DB is to AD. I'm flipping the letters. Like EB is to CE. It doesn't matter which order the letters, is the same answer. Okay, so this is what they want us to prove. Let's find out which of those choices is similar to something like we have right now. So I have my fractions. Let's say BA/BC. BA/BC, no, we don't have that. We have DA over BD. DA over BD. Okay, what they have is they took the little one. They took the little one over the big one. So this is the order they did. They did the little one. They used DA or AD. So I can just DA. All right, good. So they took the little one, DA over BD, which is the big one. And if I start in the little one this side, I have to start in the little one the other side. Okay? EC over the big one, which is BE. Alright? I can say the big one over the little one, big one over the little one, or little one over big one, which is DA over BD, and the other side as well. Alright, let's check. So DA over BD is EC to BE. You see that? So we have our answer. My answer is the last one. All right, 13. Excellent. Let's get to the next 14. 14. Let's read the problem. As always, read the problem, the questions, all the whole information. Circle A has a center at the origin. A, center at the origin, and a point D located at 1, 0. This is D. Oh, that means from A to D, that's my radius, which is 1, the little one. Circle B has a center at 1, negative 2. B, that's the center. And a point E located at the point of 4, negative 2. And this is a point from circle B, and the radius is 1, 2, 3. Got it. Little one, radius 1, big one, radius 3. Let's keep reading. Logan performed 2 transformations on circle A to show that circle A is similar to circle B. All circles are similar. It's just a matter of seeing what is the transformations. He first dilates the circle with the center of dilation at the origin and then translated the new circle. Okay, so he's going from A to B. Dilates means make it bigger. Alright, so dilation and then translation. What are the right description of the new two? Alright, cool. Easy. So guys, we're going from the little one to the big one. Alright, and when we have circles, the easiest way to do circles is to see what the radius is. My radius here is 1. My radius of the big one is 3. So I'm going from 1 to 3 to make the little one, which is xy, equals to the big one. I have to multiply. Oh, I'm not typing here. I gotta type. In order for me to make the little one same as the big one, I dilate it. By what number do I need to multiply this to get equal to 3? By 3. So my x becomes 3x. I gotta multiply 3 times my value of x. The same goes with y. The y turns into 3y. I'm multiplying by 3 because my radius is times 3. Got it. Alright, but again, my new circle will be sitting right there. Now I have to move my center from A all the way to B. Okay? From A to B. What happens? From A to B, let's see how much I move in x. I'm moving 1 step to the right. So my x value turns from x to x plus 1. I'm moving 1 to the right. My y value, I'm here now. I'm going down. That means I have to subtract. How many steps? 1, 2. So my translation goes from y to y minus 2. So then this means 1 to the right, and this means 2 down because it's on the y-axis. Let's type that. So x turns into x plus 1. That's a translation. I'm going to the right one. And my y value is going down, which means minus 2. Alright? Dilated 3, 1 to the right, 2 down. Next one. Question 15. The equation for line A is shown. Y equals negative 2/3 of x minus 4. Line A and B are perpendicular. This is huge, by the way. They're perpendicular. And the point negative 2, 1 lies on line B. So this point belongs to line B. Write an equation for line B. Alright, so the whole idea is they give you one equation, and this is A, line A. They ask you for line B. But they're saying the lines are perpendicular to each other. I just want to graph this real quick so you visualize this thing. Y equals negative 2/3 of x minus 4. The first thing that I do is my y-intercept, negative 4. My slope is negative 2/3. So that means I'm going to go down. My slope, remember, is rise over run. Okay, so rise is negative 2/3. So that means that goes down 2. It goes down 2, and it goes to the right 3 because that's my run. That's my second point. My line is something like this. Real quick. Okay, so that's line A. They're saying the line B is perpendicular to that line, therefore somehow it's a line something like that. Perpendicular. I just want to show you what perpendicular is, right? And is this line B? No, I'm not saying that this is line B, but it's something like that, perpendicular. What happened when two lines are perpendicular? Because that's the whole trick about this thing. When two lines are perpendicular, the slopes are negative reciprocals. So if my slope of A is negative 2/3, that means the slope of b is the negative reciprocal. Negative reciprocal, let's do reciprocal. Reciprocal means I'm going to flip the fraction, right? And this is negative, this is negative. That'll be reciprocal, but it's a negative. That means I'm going to change the sign of the second one. Therefore, in terms of negative, this one is going to be positive. How do I double check this? If I multiply these two slopes, I should get equal to -1. So to double check that two lines are perpendicular to each other, I multiply the slopes. -2 times 3 is -6, 3 times 2 is 6, -6 divided by 6 is -1. When two lines, when the slopes are multiplying, you get -1, that means the lines are perpendicular. This symbol means perpendicular. Alright, so this is called the opposite reciprocal or the negative reciprocal. Therefore, by having the slope of line A, I can find my slope of line B. Alright, now I have that. But they're also saying that -2, 1 is a point of B. Okay, so I need to write my equation. Y equals mx plus b. I have my slope already. I don't have my y-intercept. To find my y-intercept, what I do is I bring my slope and I bring the point that is given. The point that is given is -2, comma 1. Okay, remember, I gotta find my y-intercept. So what I'm gonna do is I'm gonna plug in my slope here. Okay, I'm gonna replace the y and I'm gonna replace the x. From where? From my point. The first value of my point belongs to the x, the second value belongs to the y. Alright, let's replace these values in this equation. Y equals, but y is 1, equals my slope times my x value, which is -2, plus b. And from here, I gotta find the value of b. Let's do the fractions thing. I need to make this -2 a fraction. Multiplying fractions, top with top. 3 times -2 is -6. Bottom with bottom. Okay. Reduce. -6 divided by 2 is -3. I need to leave the b by itself. Cancel the -3. I do the opposite, which is +3. And +3. 1 plus 3 is 4. 3 minus 3, 0. They cancel out. And I just found that my y-intercept is b. I have my slope. Let's write the equation. So my equation is y equals mx plus b. I need to replace this slope and I need to replace the y-intercept. Y equals m. My slope for my line b is 3/2 plus b, which is my y-intercept. I just found it. This is my equation. Let's type it here. Click here. And let's say that I have to, holy cow, why? My computer. Y equals 3/2. Where's my fraction thing? Here's my fraction thing. 3/2. Okay, x on the side. On the side, I think, I don't know if that's correct. Yeah, that's correct. Plus 4. Alright, and that's it. Fraction. I don't know about this. This is the denominator, and this is, I'm okay. Yeah, double check and make sure that the x is on the side, not on the bottom. Alright, and that's your equation. Excellent. Let's go to the next one. Okay, so now let's do 16. By the way, we're going to finish all the questions in this video. It's only up to 19, so we're good. A rectangle and horizontal line segment are showing, so this is showing. Question: what is the resulting object when the rectangle is rotated around the horizontal line segment? I want you to understand a couple of things. Look at the rotation. You see that rotation? That's a circular motion. Okay? So if it's circular motion, that means this line will be a circle. Okay? And this line will be a circle from the same distance. Alright? So technically, all these will be filled when I created that. And if I fill that all the way up to here, that's going to give me a cylinder. Alright, I'm going to show you a quick demonstration about that. Here's GeoGebra. So here we go, video. I just want to concentrate here. Okay, look at that, that's a rectangle. You see the circle motion? That created a cylinder. In our case, there's a space in between the center and the rectangle, therefore it's going to be open space right there. I just want you to see that that's a cylinder. This is a solid cylinder because it's right there. There's no space between the line, the axis, but in our case we have a space in here, so it's going to be an open or empty cylinder. So as we can see, out of all these possible answers, because there's straight lines, a sphere, definitely not, A is our answer. Alright, let's get to the next question. Okay, question 17. Triangles PRQ and TSR are shown. Okay, this question has 3 parts. Part A, select all assumptions that must be made about PRQ and TSR to show angle similarity. Oh, okay, so I have to show that these 2 triangles are similar. Alright, angle, meaning 2 angles. Alright, which transformation should be applied to show similarity? Transformation, okay, and then a conclusion. Alright, let's go through it. We read the problem, we read the questions, the answers. Select all the assumptions that must be made between these 2 triangles to show the angle similarity for triangles. So, guys, I need to prove that this little triangle is similar to the big triangle. Alright, the way to show similar triangles is using angle similarity, which is they're saying here, angle. Therefore, I need to prove 2 angles in these triangles. So just by looking at the triangles here, I know that these 2 angles are vertical angles. Right? So that's the first thing I need to check. So as angle, let's see, SRT is this little one, and QRP is the other one. So this is my first answer. Okay, remember, are we looking for angles or we're looking for sides? We're not looking for sides, so this is wrong, this is wrong. Alright, so out of these 3 choices, now, I have to prove these 2 angles somehow congruent to these 2 angles. Somehow. But let's pretend, and I'm gonna attach a link to another video that actually is number 17 of b.e.s.t. It's a coincidence, but it's very similar. So I'll attach in the description. So this line, if I want to find another 2 angles, remember, I'm doing angle similarity statement. Okay, I'm sorry, not similarity statement. Angle similarity theorem. Okay, that means I got to prove 1 angle from 1 triangle congruent to the other triangle, but I need a second angle. Therefore, I got to prove that this angle S is congruent either to angle P or angle Q, one of them, right? How do I prove that? If these two lines, if this line is part of this line, then I can say that there's a relationship like alternate interior angles, all right, of those angles. So that's what I'm looking for, all right? I'm looking for that. Now, let's see out of the options that I have right now. They're saying angle S congruent to angle Q. Angle S congruent to angle Q. Yeah, it makes sense. Why it makes sense? Because if this line is parallel to this line, and this is a transversal, right? Then this angle, and let's change that to blue so we can see it, then this angle and this angle will be called alternate interior angle. So angle S makes sense that it's to be congruent to angle Q. But let's see the other 2 choices. Angle S to P. S and P. No, there's no relationship because there's no transversal that touches both of them. T congruent to Q. T and Q. There's no transversal that touches them. So these are my 2 answers. Alright, so let's get this. Touch right there, answer both of them. Right? Cool. Next, part B. Which transformation should be applied to show similarity? Okay, and you see there's a rotation, reflection. Okay, if there's going to be a rotation, it has to be around point R. Because what I'm saying is that the little triangle, I'm going to rotate it and then make it bigger so it coincides with the big triangle. So it's going to be rotated around R. So rotation, reflection, no. No, there's no symmetry on both sides, so I cannot have a reflection on this side. It has to be rotation. All right, rotation R, okay, good. Rotation R followed by translating, followed by dilation. Yes, I'm rotating the little triangle. And it will be standing like over here, right? My little triangle will be something like that. But then after that, I have to dilate it, make it bigger. So my choice would be C. All right, it's not a translating, it's not a translation, it has to be dilation. Check. Excellent. Let's go for the last one. Now that's the conclusion. So my last question is the conclusion. Which conclusion can we make? Can be made from the transformations. All right, so applying one of this shows the triangle PRQ, similar. So I'm showing that those two triangles are similar. Okay, they need to have the same order of the letters. I'll choose that in a minute. Thereby showing that two congruent angles, one congruent angle, two congruent angles, and one set of proportional sides. Okay, excellent. All right, I understand. So what's going on here is the following. My conclusion, I just proved that these two triangles are similar by angle. So the two angles are congruent, right? The two angles, two congruent angles. Yeah, angles have to be congruent. My triangles are similar, so I need to follow the same order. All right, so let me clear this out. So let's find the order. My first triangle is PRQ. So I'm going from PRQ, PR and then Q, right? That's the order. Remember, angle S is congruent to angle Q, right? So if this is the order, PRQ, then on my second triangle, because Q and S are congruent, then my last angle will be S. This angle is congruent to this, so my middle letter will be R. Therefore, my first letter is T. So let's go over this again. Triangle PRQ, PRQ is similar to triangle T. I started opposite, go to R, and then go to S. All right, it's the same order, has to be the same order. So I got this one. TRS, where's TR? TRS. All right, applying what? Proportionality, no. Definition of congruent in terms of rigid motions, no. Corresponding parts of congruent triangles, no. Definition of similarity, yes. The definition of similarity in terms of similarity transformations, that's what we're talking about. We're talking about similar triangles. Shows that these two triangles are similar, thereby showing that two congruent angles are sufficient to prove similarity of two triangles. Yes, because we're looking for angle. Remember the description? The question, show angle similarity. All right, excellent. Let's go to 18 now. Okay, so let's read 18. Triangle, RTV shown in the graph. So we had that triangle. Let's read what's going on. On the bottom, it says triangle R prime, T prime, V prime is formed using transformation 0.2 of X, 0.2 of Y. This is a dilation. Because this is a number less than 1, then it's a reduction, meaning the new triangle is going to be a little triangle. And this dilation is centered at the origin, 0, 0. Select the three equations that show the correct relationship between the two triangles based on the transformation. All right, I got the answers. Let me explain that. Okay, so first of all, like I said, if this is less than 1, my new triangle, let's say my new triangle is not perfect, but I'm just going to make it a point. My new triangle is little triangle, smaller, because this is less than 1. So this corner will be B prime, this is R prime, and this is T prime. Okay, something like that. All right. Let's go through the answers. So what's happening, and hopefully you understand this. Let's pretend that this segment on the top, RB, let's pretend that that's 1. just pretend. You think R prime, B prime is going to be bigger or smaller? It's obviously smaller because my scale factor is 0.2. So how do I do it? I take my scale factor and I multiply times my RV. Oops, why did I put T? Right? Because it's the scale factor times my original. Oh, but my original is 1. Therefore, my little one is 0.2, right? If I write 0.2 as a decimal, 0.2 as a fraction, I'm sorry, is 2 divided by 10. If I reduce divided by 10, it's going to give me 1/5. So I can say that RV prime is the same as 0.2 RV, or I can say that is 1/5 of RV. All right, scale factor. I just want you to understand that the original, the pre-image, is bigger than my image, which is the transformation. So let's look at the first one. RV is 5 times my R prime B prime. But hold on, I have this transformation. So I said that RV prime is equal to 1/5 of RV, right? But they want to leave the RV by itself. So if you want to leave the RV by itself, that means you gotta cancel that fraction. How can I cancel that 1/5? I multiply times the reciprocal. The reciprocal of 1/5 is 5/1. I flip the fraction. This 1/5 times 5/1 cancels out, and I have the RB is equal to 5 times R prime B prime, which is correct. So what I want you to get a conclusion right away is by looking at this. So if I have the R prime B prime by itself, then in front of my original is going to be a decimal, 0.2, which is my scale factor. If I have the big one by itself, then in front of my prime has to be a big number, because remember, this R prime B prime is a little sign. I got to multiply times a big number, in this case is 5, to get equal to the big one. All right, now let's go through those answers. First one is right. Let's look at the second one. This is a ratio, but can I tell from here? No, I got to do cross multiplication, meaning I got to cross this diagonal, which is 0.2 square root of 26 times R prime B prime is equal to the other diagonal, square root of 26 times RB. Don't get confused with the square root. Look, it's the same thing on both sides. So this is just a number. You gotta be concentrated is on the scale factor. My scale factor, 0.2, is in front of the big number or the little one. 0.2 is the little number. It's not in front of the big one. Therefore, this is wrong. Okay, imagine 0.2 of something little is then going to be equal to something big. That's why this answer is not marked as right. Okay, so whenever you have a proportion like this, you got to go cross multiply right away. All right, let's go next. I got to erase this for a little bit. Next one, 0.2 square root 10 RT equals square root 10 RT. Same radical, doesn't matter. Ignore that radical because it's the same thing on both sides. So technically I can just cancel out on both sides. What's left? 0.2 RT. Let me see. 0.2 of RT. Yes, the original one. Remember, RT is the big one. RT is the big one. It's equal to the little one. Yes. Little 0.2 of the big one is going to give you a little one. That's right. Here, the big one is equal to 0.2 of the little one. Does that make sense? No, it does not make sense. Here, 0.2 of the little one. Why did I say the little one? Because you see the prime, T prime V prime, T prime V prime is the image. Okay, that's the transformation, which is the dilation, which is the little triangle. So 0.2 times a little number is not going to give me a big number. Cross out. I have the last one. What do we got to do? Cross multiplication. 0.2 square root 34 times the big one equals square root 34 times the little one, because it has the primes. Let me just do a simple algebraic process. If I want to get rid of this square root of 34, I have to divide on square root of 34 on both sides. What's going to happen here? It cancels. It cancels. What do I have left? 0.2 of the big one is equal to the little one. I just got rid of the square root so you can see it better. You see that? 0.2 times a big number is going to give me the little one. And that's right. And that's why those three are the options. All right? Let's get to 19. Our last one. Woohoo! Question 19. All right. Nothing underneath. Nicole, Jeremy, and Francis each perform a transformation on a triangle RST. Each recorded his or her transformation and location of S prime in the table. Point S on the triangle RST is located, so first thing they gave me is point S. So S is 5, negative 7. Okay, complete the table to determine the values of A and B that makes an algebraic description of each person's transformation true. So let's see, Nicole, Jeremy, and Francis. According to transformation, I can tell what's what. Nicole, she did a translation, meaning she went to the right or to the left with the X, and she went up or down with the Y, adding or subtracting. Okay, so she did something like this. To the original point, she added A, and to the Y, she added B. What's my original point? Negative 6. I'm sorry. My original point is 5, negative 7. My original point is 5, negative 7. Look. 5, negative 7. This is the transformation, the one that's transformed. Okay, so what happened to this point? X is 5. She added a number. And to the Y, which is B, she added a number. And then when she did that, she ended up at negative 612. Remember, this is the X values and this is the Y values, right? So what I'm going to do is I'm going to take the first part. I'm going to take the first part, and that's equal to negative 6, because this is the X equals to the X, and this is the Y equals to the Y's. So I'm going to take 5 plus A. 5 plus A is equal to negative 6. From there, I got to find the value of A. Minus 5, minus 5. 5 minus 5 cancels. A equals negative 11. So that will be going here. Same process I do with the Y's. Negative 7 plus B is equal to 12. Cancel the negative 7. Add 7 on both sides. Negative 7 and 7 cancel. B equals to 19. Click right here. That's negative 11. And here is 19. Excellent. Alright, next, let's go with Jeremy. So what happens with Jeremy? Jeremy xy it turned into ax plus by. So if you notice, there's no signs between the 8 and the x, or the b and the y. That means he's multiplying. So this is a dilation. Alright, so Jeremy, he did a dilation. Okay, because the number is multiplying. So he turned the xy into 8x, comma, by. But my point is 5, comma, negative 7. This is a y, by the way. My point is 5, comma, negative 7. That means he multiplied a times the x, which is my 5, comma, and he multiplied b times my y, which is negative 7. And when he did that, he ended up at negative 1521. Same as before, my first part My first part belongs to the x. Therefore, I make it equal to the x. So I'm going to have a times 5 or 5 times a, which looks better. That's going to be equal to negative 15. Divided by 5. 5 divided by 5 is 1, so it cancels out. A equals negative 15 divided by 5 is negative 3. I got a value of a. Do the same process with the b, or with the y values, okay? So I'm going to say that b times negative 7, b times negative 7, or negative 7b, which looks better, is equal to the y value. Divide by negative 7 to leave the b by itself, and b is equal to negative 3. 21 divided by negative 7 is negative 7, and negative 7 cancels out. Alright, I got that. What's next? So I have already, let's plug it in. So I have negative 3 is coincidence, is dilation. Alright? Is a dilation by negative 3. Okay. Alright. Last one. Francis. Oh, I gotta make this. Francis. So let's do Francis right here. Now Francis is a combination of both. You see there's a number multiplying and one adding. B is multiplying and subtracting 6. Alright, so I gotta find out is a combination of these two. So let's write that right away. So this is Francis. Francis turned the xy into 8x plus 1, comma, by minus 6. My original point is 5, negative 7. Same process as before. My original is 5, negative 7, and Francis turned it into 8x. Instead of the x, I write the x value, which is my 5, plus 1. Okay. Oops, I was not supposed to put up that parenthesis. Comma, by. But the y is negative 7. Minus 6. And now I have the big parenthesis at the end. Same process. My x equals, oops, sorry. Guess, okay, I missed something. After the transformation, Francis ended up at negative 4, 8. Negative 4, 8. Alright. After the transformation, Francis ended up at negative 4, 8. Meaning the x value equals the x value, which is negative 4. So a times 5 plus 1 equals negative 4. Or instead of doing a5, let's organize that. 5a plus 1 equals negative 4. Let's solve this. Let's solve for a. Subtract 1 on both sides, because I got to cancel the positive 1. That gives me 0. 5a equals negative 5, right? Negative 4 minus 1 is negative 5. Last step, divided by 5. So right now we're reviewing equations. A equals negative 1. Amazing. Let's change the color. Let's do, I don't know, let's do some kind of blue, I guess. And now the same process, but with the y. B times negative 7 minus 6 equals the y value, which is 8. Instead of b times negative 7, that doesn't seem right. Let's flip the order of these two, and I'm going to write negative 7b minus 6 equals 8. Solve for b. Cancel the negative 6. Is negative. Add on both sides. Negative 6 plus 6 is 0. Bring down the negative 7b. A plus 6 is 14. Last step, you divide by negative 7 on both sides. And now negative 7 divided by negative 7 is 1. Cancels out. I don't have to write the 1. You want to write it, that's fine. 14 divided by negative 7 is negative 2. So b is negative 2. Let's click over here. Let's type it. Let's type a equals negative 1 and b equals negative 2. There you go. And we're done. At this point, we move ahead. Well, let's clear this out. And we move ahead. So remember, this red means unanswered items. So at this point, you're going to go hit each one of them and you go finish. And then you wait for instructions from your proctor, okay? So guys, this is the end of session 1. Okay, let's see if there's anything else. No, I'm not leaving right now. The end of session 1. I will start with a different video for session 2. Please, you're learning, like the video please, subscribe to the channel, and make sure you hit the notifications bell, because remember, I'm going to have more videos so you can get notified when I get those videos up and running on YouTube. Alright, so in front of you, you're going to have the subscribe to the channel please. Take care. I'll see you next one. Bye bye.